So, this is one of my favorite data sets I've seen in a long time because it's so freaking weird looking. How many of you guys got a graph that looks like this?
Yes.
Me too. Me too. Me too. Yes. Yes, I love this graph because it's so freaking weird.
Wait, the second one to the end, ours looks different.
It does?
Mine goes up.
Up a little bit. Yeah.
Oh! I see that. Wait a minute. Hang on, hang on.
You miss a number?
I could have.
Not enough of
Huh. No. 131 at the end, right?
Yeah, you have 4, 5.
Did you go zoom 9 or just graph when you graphed it? Press zoom 9.
Oh.
Mine looks just like yours.
Yes. No, no, no. The question, Pam, the question is that they had a little hiccup here, and that's only because their window was a little bit different than mine. And that's the, I like the fact that we're all looking, but basically we're getting the same idea. We've got a start up here and then a huge drop and then this.
Right.
I can't explain this. Here's why. I can't explain this, and here's why. Let's turn this off for a second. Just for a moment. Go back to Excel. Let me see if I can scooch this down. Okay, that's perfect. Okay, I want us for a moment to ignore the experiment that we actually did. For a moment. I want to come back to it. But for a moment, pretend we were going to do this experiment theoretically, which means we had an idealized setup for the results we should have gotten if 185 of us started the game. How many should be left after the first pull? In other words, if remember how we did this with the coins? We could kind of theoretically figure out how many would be left because we knew we'd lose half each time and we'd leave half behind. So the number remaining.
25%.
Wait, tell me about 25%. Tell me about that. Tell me about that.
Or 1/4.
Times 1/4.
Good. That's going to tell us what we lose a quarter each time, right?
Right.
So we leave 75% behind. So what is, you got it from me, Jury? Go ahead. Tell me what it is.
It's 100. Wait, do you want the...
Give me the remaining.
The remaining is 138.75.
So let's make sure we understand this. Jury has given me 138.75. The reason she's giving me this number is what Anya said. We're going to lose a quarter every single time, aren't we? On average. Wait, watch this, watch this. Everybody get their cards. So get your cards, get your cards. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12.
I thought we were done.
16, 18, 19, 20, 21, 22, 23, 24, 25. That's damn close. Everybody shuffle your cards right now! Perfect. When you're satisfied you're shuffling, take the top card, lay it down in front of you. I'm not looking. I'm not looking. When you're happily shuffled, take the top card, lay it in front of you. I'm not looking. Raise your hand if you got hearts. I'm not looking. There are between 5 and 9 of you with your hands up right now. 1, 2, 3, 4, 5, 6. Oh wait, got 5 here and 4 here. That's 9.
Oh my
Those are the
God.
times. Do it again.
Shuffle again.
Shuffle. Don't make me beg.
You're like Rain Man.
I resemble that comment. Rain Man. 42 cheese balls. Kmart sucks. Shuffle. Wapner. We gotta be almost 5 for Wapner. We're dating ourselves. I love this. All right. Shuffle. Card in front of you. Gesundheit. Raise your hand with hearts. There are between 5 and 9 of you that have your hands up right now. Ooh, I was low on that one. Not so much Raymond anymore. Do it again. Just once. Just shuffle one. Shuffle until you think they're shuffled, and then deal 1 card. Not Raymond. We'll come back to that view. Deal out your card. When you're ready.
Hang on.
You're not shuffling very well. Either that, you got one of my rig decks. That could happen too. Okay, raise your hands if you got hearts. There are between 5 and 9 of you with your hands up. 6. Okay. Now, Rain Man, no. Betting on probability, yes. Now, notice there were different people each time with their hand up. Now, it went from 9 to 3 to 6. Notice what the average of those 3 numbers is, though. It's 6, right? It's 6. If you average those 3, it's okay. It's early. Kmart sucks. I was betting between 5 and 9 because there were go.
I have the weirdest thing that happened.
Tell me.
But I drew a 7 of hearts 3 times.
That means you shuffle
And then-
suckily. Kidding.
8 of hearts, and then I drew 8 hearts, and we both drew a 2 of hearts.
Oh, dude.
Wow, we always had the same situation.
Do it again, right now.
Rain Man, you should kind
We
of.
got hearts.
I love random. What you're describing is called random clumping.
Okay, 2 times.
You're seeing random clumping, okay? You're seeing random clumping. The thing about random clumping is it's guaranteed, but you never know when it's going to happen. It's going to happen somewhere. You just don't know where, and this is what Monday's all about. Population growth is actually more predictable. I'm talking about if you throw things like dice, coins, or cards, little clumps actually do occur in the data. It's just that you don't know when they're going to happen. What'd you guys just get? What'd you guys just get? Ace of clubs, 5 of diamonds. See, the clump is dead. But that's okay. We got the 9 of hearts behind us, though, and the freaking 9 of hearts behind you. I'm telling you, I don't know why I just did that. The thing is that those clumps do happen. They are predictable percentage-wise, but you never know when. It's kind of like Doc Brown. It's like a bolt of lightning. You never know where or when it's going to strike. You don't. You don't know when the clump's going to happen. You don't know when that streak is going to happen playing craps. You know it's going to happen. You just don't know when. And that's why you can't bet for investment purposes. The clumps happen. The trick is, if you get a clump, you stop right after. Because if you keep going, it's going to even itself out. Yeah, same thing with all gambling. If you treat gambling like entertainment, don't worry about it. Go in and lose your money happily. But don't think you're going to come back out with more than you started with, because you're not. There's a reason to keep their lights on. There's a reason the fountain of Bellagio is in the desert, for God's sake. Think about that.
Yeah.
They have how many millions of gallons of water in the middle of Vegas?
Right.
Why? Because they can afford it. Now, let's go. Oh, Amy, go ahead.
Except they do kick you out if they figure out that you're so smart that you...
That you're counting cards because you're ruining the probabilities. We'll come back to that. We'll come back. It's kind of the end of this class is tying this all to gambling, and yes,
You can count cards. You can.
it's totally legal. They will ask you to leave.
Legal. They'll ask you to leave if you do it enough.
And you get caught if you do it obviously enough to get caught,
If
right?
you're still pulling in people to play with,
You're making the money.
You're making them money, enough money. This is a side tangent, but there's a really interesting
There's a balance point.
documentary about Christian gamblers who would like flood these
Interesting.
casinos as a lifestyle.
Oh, interesting.
What would
And
Jesus
then-
do?
You
What would
gamble.
Jesus
You
do?
gamble well. God.
Give it away.
Yeah, give it away after they won the money.
What Anya's described, if you guys have not watched 21 or read the book Bringing Down the House, it's a fantastic book. The book's even better than, believe it or not, the book's better than the movie, which is hard to believe because the movie's pretty darn good. But yeah, there's neat math behind that. And it's not illegal. Nobody got beat up in real life, FYI. That was totally Hollywood. But the idea is they don't like you counting cards because they're taking their revenue from it. It's not illegal because they can't prove you're doing it, basically. Anyway, why was I betting on 5 to 6 or 5 to 9? On average, there are 25 of you in the room. How many should get hearts each time on the cards?
About 5.5 or 6.
25% of you, right? Which would be 6.25 of you. So I said, okay, 6.25. I rounded to 7 for some reason in my head because I'm Rain Man. And then I said, I'm going to go up or down 2 from 7 and hopefully catch what happens. Now, I did a pretty good job. I got 2 out of 3. One I missed, but the one that I missed was balanced by the one that was over. And it came up being on average 6. That's what statisticians do all day. They try to catch the average of an average that's moving around. But they check the behavior. It's pretty badass. So it was kind of Rain Man-ish, but very, very low grade Rain Man. Very low grade Rain Man. Yes. Kind of the Kmart doesn't suck so bad Rain Man.
Young Rain Man.
So is everybody beyond Rain Man? So do you see where this came from? There's 2 ways you can view this. You can view this as we took 185 minus 25% of 185. That's one way of doing it, right? We're going to lose a quarter of you on average and leave behind the remaining. Or, if you like, you could just do 0.75 times 185, right?
Yeah.
That's another way of doing it, isn't it? They're equivalent, aren't they? Instead of counting the number that we throw away and then take that away again from 185, just calculate the ones that are remaining. If we're losing 25% each time, we're keeping 75% each time. Does that make sense? Hence, why I call this the maintenance percentage. That's why I call it the maintenance percentage, because you maintain that percentage each time. Does that make sense? Yeah. There's two ways you can view it, of course. Now with the coin flip, it didn't matter, because it's 50-50. If you lose half, you keep half. It gets more interesting when you move away from the half, and you have to look at the two different sides of the, if you will, coin. Fair? So theoretically speaking, how many should we have after 2? How many remaining should we have after 2?
0.75 times 138.7.
I love that. We're going to take 0.75 times this, aren't we? 75% of those that remain after the initial? Is that believable?
Yeah.
What does that end up being?
104.06.
Thank you. 0.06. Now what's cool about looking at it as from the maintenance percentage, could we also have just done this? 0.75 squared times 185. So I'm not, instead of using 138.75, go all the way back to the beginning and apply 75% twice. So the first 75% gets us through the first round, the next 75% gets us through the next round. Does that make sense?
Yes.
And the reason we like doing it that way is why? Because it's way easier. That's why we do mathematics. We do mathematics to consolidate, not to make things... This is probably making you sick a little bit, all these minuses and time. Let's consolidate. Let's look for the pattern. Every single time we go through another round, we're maintaining 75% of those left. So, we just keep doing 75% each time. So the next one's going to be 75% cubed times 185.
185, yeah.
Is it okay if I switch? Can I put the 185 in the front? It's messing me up having it in the back.
Me too.
Yeah, so let's switch them around. So down here it's going to be 185 times 0.75 to the fourth.
Yes.
185, 0.75 to the fifth. I know you guys are probably actually figuring out the numbers, aren't you?
Yes.
Good for you. Can you give them to me? What's this one here? This is the cubed one. I want to guess it's about 75, 76, 77.
78.05.
There we go. We'll call it 78. Let's call it, just to make life easy, we'll call it 78. It's cute. What's the next one now? I'm going to guess it's about 56.
58.53.
58.5. That's fine. Thank you, Marion. I'm going to lose 25% of that, which is going to be about 43, 44?
We went on number 5?
Yeah.
44.
44?
Yeah.
Beautiful. You see the pattern? I'm not even really that much interested in the number out there. I'm interested in the pattern that's generating that number. Every single step down, we multiply again by 75%. So this should be an exponential model, shouldn't it? We're losing 25% each time, which means we're maintaining 75% each time. Is that fair? You guys buying that logic?
Yeah.
So if we get, suppose I want to jump all the way down to this 13. My God, this poor person had 13, whoever that was, I apologize. 13 until you saw hearts. We could figure out how many people should be in that category. And we don't have to come all the way down from 0 to get there, do we? All we got to do, Jury, go ahead.
It's 185 times 0.75 parentheses caret notes.
To the 13th power. That's how many people should have been left. What does it come out to be?
4.4.
We should have had more of you. How you like me now? Don't answer that question. But that's the thing. It's actually predicting there should have been more of you at the end than we had. Ooh, which begs me to ask, oh, hot damn, how about 14? Right? Because there should have been about 3 of you, right? At this point?
3.0.
Uh-huh. How you like me now? There should have been 3 of you. Think about it. If there are 4 of you here, we're going to lose 25% of that 4 to the next round. Which means 3 of you are going to keep drawing. Does that make sense?
So it's me.
Yeah, it's the maintenance. We're maintaining 75%. Now, your data, So I think we have an equation, don't we?
Yes.
I think we have an equation. We've got an equation, and that equation is if I have X draws, not 0, not 1, not 2, but X, the number remaining after X draws, let's puzzle it out together. What number is constant through all these calculations? The 0.75 and the?
185.
Good, those are the two constants, right? Those are the two constants. It's the 185 times 0.75.
That's why the variable is the.
That's, Anya, you got it. That's why the variable is the exponent, because that's the only thing varying is how many times you draw the cards. Pretty badass, huh? Now, if you would be so kind, slap that equation into y1 and graph it with your data. And marvel in the goofiness. I'm gonna marvel, I'm stoked.